For this first lecture, March 30th, Monday, March 30th, we're going to continue on talking about how you measure diversity within communities, recognizing that there's a lot of different communities, some diverse, some not very diverse, and a lot of them in between, different ways of expressing it. It's not like you can go out and say, well, this community has a diversity of 1. This community has a diversity of 1.1. This one's more diverse than other. You can do that, but there's different definitions of diversity, and so it's not as straightforward as going to the diversity store and shopping around and saying this community is diverse and this one isn't, as we'll see. So when we left off on Friday, we were looking at these different ways that you can quantify diversity in communities. And so one of these is the species richness. You can just count the number of species. We're going to go through a number of different types of these. Diversity. How do you measure diversity? I pointed out on Friday why people are so interested in this in the first place. So hopefully that's fresh in your mind, or you can go back and look. There's a number of different reasons why people are really interested in diversity. Not just ecologists, not just community ecologists, but humans in general. So one way of explaining measuring whether a community is diverse or not is just counting the number of species. As I said, it's not that easy. Some species are really hard to find. Some species are very cryptic. Some species are only out at night. Some species are in very places hard to find. But you could do this, by counting the number of species that are there. You don't have to count how many spiders there are, how many different types of individuals there are within a species. You just have to know how many species there are. No index of abundance. So you might find one individual of this species. You might find 10,000 individuals with other species. They count the same. There's one species, two species. One of them might have one individual. The other one might have 10,000. But for our purposes, or the purposes of this species richness index, then it still counts. There's two different species. Two species. So people don't like that so much because they think, well, it doesn't really reflect how diverse a community is. You could have two communities that have 100 species and say, well, their species richness is exactly the same. But one of those communities would have an equal number of individuals that make up a bunch of those populations, whereas the other community, with the same number of species, 100 in each one, might be really, really, really dominated by one species. So there's two communities, both that have 100 species. They're not the same. In terms of species richness, they might look the same, but they're made up of different community members. They function very differently. They have very different characteristics. So there's this idea of not just number of species, but the abundance of these different species. And then there's the idea of trying to combine these as much as possible. So that's what we're going to look at in terms of these different indices. There's a dominance index that people have come up with. So you've got you're counting the number of individuals in populations. And you're saying, okay, the one that's most dominant, we looked at 100 different species, and the one that has the most number of individuals, or in other words, the highest population, is species A, species X, whatever it is, some species that's more common than anybody else. And so for every other species, you've got this one species that you found 1,000 of. You got this other species you found 900 of. You got another species you only found 700 individuals, and on it goes down your list. Then you can look at a dominance index that reflects how all these other species relate to the most dominant species. So let's look at that. Here's an example of using the dominance index to examine diversity in two different communities, Community 1 and Community 2. Now this is very simple, unrealistic, but this gives you an idea of how this dominance index would work in terms of you evaluating whether Community 1 was more diverse than Community 2, or whether Community 1 was even diverse, or Community 2 was diverse. So some of these indices are going to go from 0 to 1. Some of them are going to be more arbitrary, 1 point something or 2 point something. What does that mean? It's, again, on their own, they may not mean that much, but compared to another community, it might be a lot more informative. So here's Community 1. Both of these communities have 100 trees. You go out in some woods and you count 100 trees within a certain area. In Community 1, the most common species only has 10 individuals. 100 different species, the most common one, there's only 10. So that's a pretty, you divide 10 by 100, you get a dominance index of 0.1. That's low, close to 0, and what that tells you is that no one species is particularly dominant, or in other words, there's a lot of species that are pretty abundant. It's a very quick and easy way of getting some estimation of whether a community is diverse or not. Community 2, on the other hand, has 100 trees, just like Community 1. But in this case, there's this one species that accounts for 55 of those 100 individuals. So the most dominant species has 55 individuals instead of 10. There's still 100 different trees, but this dominance index is pretty high. It's 0.55, which is much higher than 0.1. And so in this case, the closer you get to 1, then the less diverse a community is if you're using the dominance index to assess whether a community is diverse or not. And as I said, it's not just, well, I found this one is 0.1, this one is 0.55, I'm done. But there's more that goes into that. The thought is that this one community that's pretty diverse has a whole bunch of different kinds of interactions that are taking place, functions very differently than that other community that has it's less diverse, has a higher diversity index or dominance index. There's a number of different diversity indices besides that dominance one. One of these is an evenness index, which is similar to that. It's basically reflecting how many different species there are and the abundance of each one of those species. So evenness. And in this case, you can compare the diversity. You can reflect on how diverse a community is by looking at the diversity that you observe in relation to the maximum possible diversity, or in other words, evenness, and get an idea of whether this community is diverse. There's an ideal diversity where all the different species, based on their abundance, would be very evenly distributed, or whether one species dominates over the other. So in this case, you go through these exercises, you go out and you count numbers of individuals of these different species, and you come up with these evenness indices. And you can compare that to the maximum evenness in a community. And you can see in this case, this example, the evenness that you observed was 1.2. The maximum amount of evenness that this community could demonstrate is 1.6. which is how it might be in other communities, or if you looked at if you calculated the maximum number of evenness. So that gives you a value of 0.75. And in this case, the closer you get to 1, the more even a community is. So the closer that this observed value gets to the hypothetical maximum value, then the more even that community is. And the closer it gets to 0, the lower it is, then the less even that community is. And if you're using evenness, the evenness index, to get an idea of whether a community is diverse or not, then ones that have a high evenness index, close to 1, you'd say, okay, that's pretty diverse. And the ones that get closer to 0, you'd say that is a low diversity. Another way of measuring, estimating, quantifying diversity in a community. Now, I mentioned before that there's a number of different indices that are based on uncertainty. So the idea is that you're using probability. You're using the mathematical equations to estimate the probability. The probability is, or the uncertainty is, if you go out and you select an individual, you find something crawling along, you find something growing. If you sample that, what are the odds that that individual that you found is a certain species? Species A, species B, species D, how many ever species there are. So if you look at this example, we're using letters to represent species. So if you look at this example, you go out and you collect something. Oh, what is this that I found? It's species B. What's this one that I found? That's species B. Another one, species B. Look at all these different species B, species B, species B. So what are the odds that the next individual that you collect is going to be species B? Well, it's pretty high probability. It's a pretty low uncertainty that there's a lot of not uncertainty, but there's a lot of certainty that the next thing that you find is going to be species B. So in that case, this would be a community with a low uncertainty, a high probability that you're going to find the same thing that you found in the first place. A low diversity within a community. Let's look at this other community. This community is made up of species that are represented by letters A through Z. So the first thing you find, what is that? That's species V. The next thing, oh, there's that species B that we found in that other community very commonly. The next thing, species H. The next thing is species Y. The next thing is species E. So what's the probability that you're going to be able to predict what the next individual that you're going to find is? It could be anything. There's not a very good probability that it's going to be species B, like in that first community. In fact, there's a very high uncertainty. You're not able to predict what that is. It could be one of 26 different species. It could be V, it could be A, it could be something that we haven't even encountered before. So you can use that type of probability or that type of uncertainty to estimate a value or calculate a value of how diverse a community is. If it's a diverse community, then the next thing that you come across could be anything. It could be any member of that community. If it's a low diverse community, then you have a pretty good idea what it is you're going to find, because there's not very many individuals of very many species out there. So that's an example of this diversity index. There's the Shannon-Weiner index, there's the Simpson index, there's the Shannon-Weaver index. People have played around with these and say, I don't like this, I'm going to change this. I don't like this log, we're going to use the natural log instead of the regular log. And so let's look at an example In this case, there's the Shannon index, and the Shannon index was modified by other people, but it doesn't matter. Like I said, if you want to use one of these, you're going to look this up and you're going to plug whatever values you have into your equation that you're deciding to use. So, but let's look at an example of the Shannon index anyway. You've got 5 different species. You're not going to find very many communities that only have 5 different species. But let's say, for the sake of illustrating how this index works, we're limiting this to 5 species. So you go out and you count how many individuals there are of species 1. We found 50. How many individuals of species 2? 30. And all the way down to species number 5, where we only found 1 of those. If you add all of those up, you found 100 different individuals of these 5 different species. And then you have the probability of encountering species 1. You have the probability of encountering species 2. The probability of encountering species 1 is pretty high because it's 50-50. The odds are, if you go out and you find something, that you have a 50% chance that something is going to be species 1, because 50 of the 100 individuals that make up this community are species 1. And then you can see the probability goes down, where the probability of encountering species number 5 is 1 in 100. Very low probability. So if you add up all these different things, if you sum the probability of encountering these 5 different species, you get a Shannon index of 1.2. So what does that mean, 1.2? Well, you can tell by this particular community being dominated by species 1, and this particular community only having 5 different species, that this isn't a very diverse community. If you went in a real community and had 100 different species and these different abundances, then you'd certainly get a Shannon index of higher than 1.2. They're typically 1.5 to 3.5. But again, it's just some number. If you don't have the capability of comparing Shannon indices from a number of different communities, then you have no idea what 1.2 means or 3.2. But if you do comparisons amongst different communities, you see this 1.2. Wow, that is really low compared to most communities. And so you get the idea that this is not a very diverse community, which you would expect from those numbers in the first place. Well, then Wiener came along and said, well, okay, the Shannon index, that's a good start, but I'm going to modify this. I'm going to use the natural log instead of the regular log. But it's the same principle, that if you measure the abundance of these different species and see how many species 1, how many species 2, how many species 3, and on you go. And that's the index that you use. You use a different log, but it's basically the same thing. What's the probability that you're gonna get species 1 or species 2 or species 3 or species 4? The probability of encountering each one of those is going to be influenced by the abundance of each of those. And you go out and you calculate the Shannon-Wiener index of diversity within different communities. Then here's a Shannon-Wiener index for a number of different locations on a river at in 2 different years. So you see, you count these number of species, and you count the number of individuals of each of those species, and you calculate the Shannon-Wiener index, and you can see that for each year, 2003 and 2009, you have a Shannon-Wiener index estimating what the community diversity is. For each location along the river, on this side of the river, on that side of the river, this distance down the river, you also collecting species, counting the number of species, and you're counting the number of individuals of each one of those species. So you have a Shannon-Wiener index of 2 different years, 6 years apart, and 12 different locations along this river. And so you can get an idea of what kind of changes have taken place in diversity and where. And you can get an idea of where along this river the greatest diversity is and where the least diversity is. So if this was a river that was of particular interest to humans, or maybe there was some kind of change that had taken place, development or pollution, you might really be interested in the changes that had taken place between 2003 or 2009. You might be really interested in what's happened here on the left bank, certain location, versus the right bank. Those kind of reasons why you'd be interested in this, and why you would use some diversity index like the Shannon-Weiner index to examine these. So another similar type of application is that you want to know what's happened over time. What's happened as a result of, most of the time, not all the time, but some of the time, human interaction with these communities. So in this case, you would look at diversity index along the edge of a location, on the trail, or farther away from trail, farther away from humans. See how it's been affected by some human development. So in this case, the interest was looking at the diversity index, using some diversity index. And this is the species richness, 1, and the Shannon-Weiner index, 2. Those are 2 different indices of diversity. And they looked at 3 different locations to see how these have been impacted, or how they differed in relation to their what's ever influencing them, whether it's humans tromping along on a trail, being in the interior of this habitat far away from human influence, or be on the edge where they're impacted by different factors, wind and exposure, those kind of things. So in this case, using the Shannon-Weiner index to compare these different locations, and not just that, but using 2 different indices of diversity, richness and the Shannon-Weiner index of species diversity. Well, let's look at a couple more things. We can not spend a whole lot more time on this, but using the Shannon index, for instance, to see how well a community has recovered, or to measure recovery. Here's this mining that was going on. This mine closed down. They covered up with this mine and turned it into softball fields. Maybe they turned it into a park, softball and baseball fields. Maybe they turned it into some natural area. But in this case, the interest would be using some diversity index, whether it's a Shannon index, or whether it's a Shannon-Weiner index, or whether it's something else, to compare what kind of changes have taken place over time, or in this case, what kind of recovery there's been. Now, a softball field or a baseball field might not be as diverse as a grassland, but there's still going to be certain species there. Maybe the surrounding areas, it's going to be a lot different than a mine. So in this case, they looked at a mined site, they looked at the restored site, and they looked at some place that was never mined and never restored at all, and compared diversity amongst those 3 different places. And so they came to the conclusion that this restored site, obviously it's much better than a mine, but it's still, there's some shortcomings between completely restoring this to the conditions that would have not been experienced if it wasn't mined. Well, let's look at 2 more things then. Another way, say you don't like those diversity indices, you don't like those uncertainty things, then is looking at using rank abundance curves. So basically, you're looking at different species. These curves on the x-axis, it would be species 1 and species 2 and species 3 and species 4, all the way down. It could be 20 species, it could be 100 species, but they've all got a certain abundance. So there's 100 of species 1, there's 90 of species 2, there's 80 of species 3, on and on down. Well, this just shows it's kind of like the evenness index, where this red curve on the top, you've got quite a few species that have a similar population size. And so you look at that and think, well, there's a number of different species that have similar populations, a lot of interactions that are taking place amongst these different species, high diversity. And then the blue line, you could drop down pretty quickly from species that are particularly abundant and quickly get down to species that aren't very abundant. And so these are just two made-up lines, but you can imagine that blue line dropping down very quickly. And so you're using this as an index where you can see how diverse a particular community is. You could compare two different communities by using abundance curves rather than these other indices that we looked at. Another way of looking at diversity are by similarity indices or by difference indices. So in this case, the idea is not to come up with some number, 1.2, 1.3, which doesn't really mean anything, but to compare diversity between two sites or between the same site at different times. So there's a number of similarity indices that take into consideration a lot of the same things that those uncertainty indices do. But basically, you're comparing site 1 and site 2. You're comparing site 1 in 1983 versus 1993. Those kind of comparisons. So these similarity indices, you're not doing this with just one community and coming up with a number, 1.2, that whatever that is. But you're comparing two communities, seeing how similar they are. Those type of indices, there's the Shaner index, there's the Morishita index. The Horn didn't like the Morishita index, so he modified it to the Morishita-Horn index. There's the Jaccard coefficient. Well, let's look at one of those and see how you might use those to examine similarity between two different communities, whether that's two different locations or the same location at two different times. So here's the Jaccard coefficient. You've got the different types of species, species A and species B and species C, and you've got different numbers of those, different numbers of species A and different numbers of species C and different numbers of species B. So you could imagine a situation where you had three species, A and B and C, and there were 10 of species A and 10 of species B and 10 of species C in community 1. And you went over to community 2, and there were, again, 10 species A, 10 of species B, 10 of species C. They're the same in terms of the number of species that you have and the number of individuals in each one of those species. So in this case, they are identical, basically. You're not going to find that. They're not going to be exactly identical. But you could compare community 1 and community 2 and come up with an index. In this example here, with this 6 of one species and 10 of one species and 3 of one species, in terms of how similar they are, that you find in both sites, and come up with a Jaccard coefficient of 0.32, which is pretty low. 0.92 would be pretty high. 0.32 is pretty low. So that's an example. If you're looking at community 1, community 2, you could look at community 1 and come back to community 1 20 years later to see what they have in common in terms of the abundance of these different species. The more abundant they are, the higher these similarity indices are going to be. There's also some difference indices that you can use, not to see how similar they are, but to see how different they are. So So those are some examples of how you can compare two different communities, or how you can compare changes in communities over time.